Our next experiment is calibration of dynamometer type power factor meter. Okay, to test and calibrate the given three-phase electrodynamometer type power factor meter. These are the operators. These are the operators required to do this experiment, and this is the circuit diagram for dynamometer type power factor meter testing. Okay, so this is one watt meter and this is also another watt meter, and this meter only we need to test it here, and this is not general normal watt meter, and here this one is a variac, and this one is one voltmeter, and here one ammeter, and load is a resistive and inductive load. Okay, RL load. So by varying this RL load, we can take different readings. We will note down those readings in this tabular column. Voltage, what is the source voltage we are giving, and load current, and wattmeter reading, and power factor we need to calculate by using this formula, and power factor meter reading. Whatever the meter we are testing here in this circuit now, that meter reading we are writing here, and normal general 1 watt meter we are taking now, so that watt meter reading we are writing here. This one is E1 and this one is E2 we are going to take, and percentage error we are calculating by using percentage error. So that is equal to calculated value. Theoretically we are calculating one value, power value, so that value minus actual reading. Actual reading we are taking in that meter now, that reading value by actual reading into 100, then we are getting error value in this experiment. Okay, this is the graph value. Practically we are going to do this experiment. Here we need a one variac, so this one is one variac. Okay, auto transformer, and then we need a one voltmeter. So how much voltage we are taking across this auto transformer or a source voltage, that one we are measuring by using this voltmeter, and then one ammeter, and here wattmeter, two wattmeters. This one is one wattmeter and this is another wattmeter. Okay, this is the actual testing meter. Okay, and here we are taking one resistance and one inductive load. So this one is totally RL load, but according to our experiment we are taking a variable in resistance and variable inductance, but here we are taking not a variable inductance, it's a fixed inductance. Here we are taking 0 to 250 millihenries inductance, and this is a 150 ohms resistance. So this RL load is a fixed value, fixed load. No, that's why we are taking only one value, or otherwise we need to vary the source voltage. And related to source voltage, we are taking a wattmeter reading, whether that wattmeter is working properly or not. Okay, most of the cases here we are taking RL load is a variable load, so by varying that load only, RL load only, we are taking a different readings in this tabular column. So according to procedure also same, you can observe here by adjusting the resistance and inductive load, so we can take the reading values. Okay, but here we have taken a fixed RL load, no? So that's why we are taking only one reading for 220 volts, and what is the current value, and what are the wattmeter readings we are taking here. Okay, and first we are going to do a connection, variac to ammeter first. You can forget about this voltmeter. First you need to think about the ammeter. So from variac to ammeter we are going to connect. So variac phase is connected to ammeter. Okay, ammeter first terminal, and ammeter second terminal. This one is first terminal and this one is second. So that second terminal is connected for wattmeter M. This is the second terminal of the ammeter. That one is connected for M of the wattmeter. And MC we are going to do a short circuit here. MC we are doing a short circuit here because already we know that this MC is a short circuit, and then L is connected for another wattmeter or a testing wattmeter M. This L is connected for testing wattmeter M. Testing wattmeter M. Then again L, testing wattmeter L is connected for resistive load. So here testing wattmeter L is connected for resistive load first terminal. Then resistance second terminal is connected for inductance first terminal. Resistance is connected for inductance first terminal. This is inductive L load first terminal. And the second terminal of the inductor is connected to return back to the source voltage. Return back to the source voltage of variac. Okay, that one is a neutral point of the variac. So here this one is a phase and this one is a neutral. Okay, then overall this one is completed. Then 2 wattmeters V connected to source side or otherwise load side. 2 wattmeter V. This wattmeter V and this wattmeter V. 300. These two are connected to source neutral point. So it's mean here we have a inductive load second terminal and testing wattmeter V and general wattmeter V. These three we are going to connect at neutral point of the auto transformer, and then we are taking one voltmeter across the auto transformer. It's mean one terminal is connected for ground, another terminal is connected for phase. Okay, so across this variac we are taking one voltmeter. It's mean by varying this variac how much voltage we are taking, that one we need to measure by using this voltmeter. Then I am going to turn on the power supply. Circuit is completed overall. Okay, then I am going to turn on the power supply here. Okay, then I am going to vary this variac. You can observe the voltage in voltmeter. Voltmeter reading is varying by varying the variac. Okay, up to 220 volts I am going to vary here. Okay, you can observe here current we are getting approximately 1.6 or 1.7, and here wattmeter reading is approximately 48 or 49, and then testing meter reading also varying. Here you can observe (15 watts), but here according to this the multiplication factor is 8, because the connection here you can observe B1 and as well as E2, B2 and E1. For such kind of connection we are going to take multiplication factor is 8. So it's mean 8 into 15. That is the actual wattage of this testing meter reading. Okay. So then again we need to vary this resistance and as well as inductance, then only we can get it. We can take at this fixed load place, we can take one inductive box in the sense, then only we can vary this inductance and resistance, then we can take a different reading values in this tabular column. Okay, or otherwise you can vary the power supply also, you can take different readings. So I am decreasing here voltage value, then you can observe here testing wattmeter power also changing. Okay, so whether that one is right or wrong, we need to take, it's based on the 136 volts and as well as here current value. Okay, because power P is equal to V into I, no? So that's why these two values you need to take it in the sense that the multiplication factor is equal to this power wattmeter reading. Okay, this is the actual experiment of the calibration of dynamometer type power factor meter.